Okay. Well, the analyzer is used to correct 3D pictures, which which have, for instance, the rig. There are mechanical misalignments, so it's impossible to make them optimal. You need a correction software which analyzes the pictures and corrects them by every pixel. And therefore it is a stand used. It can be used for post-processing as well, but the main purpose is for real-time application to process the pictures in real time and send them out correctly. And this was also used on the concert for Fantastische Vier, where we used the system to correct the pictures on the fly and send them out to different cinemas. And the purpose is here you can analyze the geometry between the pictures, and you can also analyze the depth between the pictures. So here, as I said, is a depth budget. So this here is a screen plane, and the red to yellow is in front of the screen. So currently we have almost everything in front of the screen. And the analyzer can be used to correct the settings so that it stitches the pictures so that everything is behind the screen, or we want 1% of the total parallax before the screen. Like every stereographer have their own settings.
Can I ask something?
Yeah.
Are you calculating 6 features between the two things? Because I noticed from...
Well, it's a feature detector developed here on the institute. No, it's not SIFT.
Because it seems like.
Yeah, it's. I can't tell so much about the feature detector, but I know this is developed here in the institute. And so the main purpose is here that the analyzer can correct the views, so it can correct the depth like you want to have it. Yeah, and this is automatically. I can show you the output of the analyzer, so you can see in 3D.
Can I capture Thank you.
And what happens if you change some of the parameters? It responds, it reacts in real time?
Currently it is in automatic mode. It automatically corrects geometrically differences like misalignments, vertical or wall misalignments, and it corrects the current depth budget, so that everything is behind the screen or like you want to have it. And for instance, if I change something on the rig, the analyzer will calibrate it as well. So if I move the pitch axis, and you see, well, the analyzer corrected. Yeah, it moves to the correct position. So you can,
So what you're doing right now is what a cameraman would do, right? Change somehow the system and...
Yeah. For instance, if you have such kind of rig on a crane, you can't if something, if the camera moves, or I don't know, on the crane everything can happen, and there comes to a misalignment. You can't move the crane down and correct everything again. There it is better to use such kind of onset tool which corrects it in real time.
Mm-hmm.
So no matter what position.
And if the operator do zoom, what happens?
Well, zoom, we have here a zoom lens. Can show you. So you can't zoom that far. There's kind of a gap, but you see it. It follows the zoom.
It follows the zoom.
Yeah.
So for the
sorry. So for the console we have seen before, you just only need one stand operator. Five cameras, 5 double cameras. How many persons for controlling the stereoscopic of each pair of
Well,
cameras?
we had each 5 camera pairs, and in the OV van there was one operator for all those kind of camera pairs.
Only one.
Yeah, because we captured the signals and we saw them on the OV van and they switched
Yeah,
all the
because it
signals
is
to each
supposed that
other.
it's automatic.
Yeah, and every signal. So you need one analyzer for 5 camera pairs.
Okay, good, very good.
So for the Fantastic Four concert, how did you map the depth values into which, place? So right now you showed us that it was like all red because it was all in front of the screen.
Yeah.
Then you switched it to.
On the Fantastic Four concert, we every camera pair was parallel. We had this is kind of keystone issues. If you move the cameras to each other, you have a keystone. You have some misalignments in the picture between the pictures. So they were captured parallel.
Okay.
And to change the screen plane or to change the object that they are behind the screen plane, the analyzer uses some kind of shifts the pictures to each other. So the objects are behind the screen. So the capturing was parallel,
Okay.
but the correction after that was that we shifted the pictures to get the objects behind the screen.
Is there any reason for that? Why did you prefer them to be behind the screen?
Yeah, well, for cinema, for instance, it's not so good to put everything behind the screen because if it's too much and you see the pictures, the eyes will get divergence between each other. So this is not.
You mean if there's a big difference in
it's a big difference to capture for TV or for cinema applications. So for cinema, it is not that bad if a big if some objects are in front of the screen because you have more depth budgets in front of the screen than behind the screen in cinema because the screen is so big.
Sure.
So the stereographer decides how much is behind and how much is in front of the screen.
Okay, so you had a person manually setting those values
Yeah.
before they are transmitted to the cinemas.
Yes.
So there was like a delay in the.
Yeah.
Okay.
So the stereographer decided what kind of depth we want to show, and then it was transmitted.
Okay, sure. You were showing us the the software earlier and had these 3 areas, like a red area, green area, and a blue area, right? What do those represent?
But these areas are the red area present that this is the object is comes very far out of the screen. So
Okay, so just
it's not that good. In the middle area is a good area because this is the area our depth budget is set to. So
Okay.
what we decide should the depth budget, how much is in front of the screen, how much is behind the screen. And the blue area is that it's far behind the screen.
okay, but you tried to keep the whole concert inside of the green area, so you kind
Yes.
of remapped it always. Okay, sure.